Hello and welcome to Learn Synthesis with Pure Data, Season 1, Episode 5. In this episode, we are going to be taking in Midi data and translating it to audio. At least just the basics right now as we build our synthesizer. Basically, we'll be able to play notes with our oscillator by using a Midi controller. So, here we go. So at this point, I guess it would also be good to mention, for those of you who do not have that was me opening up the patch while I was still talking to you, and it makes sound good. Well, in any case, for those of you who do not have like a physical MIDI controller, I think that if you're going to be learning synthesis or involved in synthesis, you'll want some sort of MIDI device. Can't get one right now. Good thing to do would be to look at some of those virtual MIDI devices out there that are software-based things that, for example, Touch OSC, that's TOUCHOSC. That also comes with a MIDI bridge where basically you can use a tablet, iPad, phone, Android, or Apple, and you can basically use your phone as like a device where it gives you like MIDI controls that you can then use, and those things would, through your home network, connect up to like a virtual MIDI port that you would then use in Pure Data. I don't have time in this lesson to go through that. It's best if you have like a USB plug-in MIDI device. It could be a small one, a small keyboard that also would fit in your backpack. It's very useful to have some sort of MIDI controller of some sort that that you have access to. In any case, I'm going to go on with the lesson, but if you don't have any hardware MIDI controller, check out Touch OSC or do some searching for a virtual MIDI controller that would basically be able to be set up as a MIDI device in Pure Data or anything really, anything that's compatible with MIDI, and then you are able to control software with that device. So, or that software on your device. So anyway, let us get here to our patch so far. Now, as I've been saying, this is going to become a synthesizer. And so I'm going to kind of do a little arranging here. This is the patch we made last week. This is our sound producing oscillator. And this one here is the amplitude modulation, which will be a section we'll be coming up to soon. We produced both of these just so you could see how to make these 4 basic wave shapes in multiple waves. Being able to wave shape directly with math is one thing you need to know to understand synthesis well, and that's why we did this. And then this one we did to show another way of making these wave shapes that employs harmonic strengths and the summing of sine waves, called additive synthesis. These are foundational things that you need to know about in synthesis, and so that's why we did them. But now we are going to be going on and starting to hook things up to make this into a synthesizer. And so in this space up here, I'm going to make another subpatch that will be our, I'm going to minimize, oops, did the opposite. I'm going to minimize this PD window. We'll look at it if we need to. I'm going to get this out of the way too. And basically in this space is where we're going to put our MIDI input. Now I believe these are 150 wide, and there's going to be a little space in between each one, but we're going to be laying out modules here and have our MIDI input at the top. We may adjust sizes in the future, but right now I just want to get a size that works for the time being. So anyway, here we go. Control 1 to make an object. And when you want to make a subpatch, remember you type PD space and then a name for the subpatch. One word or one continuous string of characters. In this case, I'm going to call it MIDI underscore input. And click outside the object and you see this window open. This window is the internals of this object we made here, which is called a subpatch. The internals is called the child patch, and of course the outside here where this subpatch is being placed is our parent patch. So our synthesizer is the parent patch, and the different modules that we're going to have in the synthesizer are going to be subpatches or child patches within it. And MIDI input will be no different than the others. I'm going to enlarge it right now. And remember, we are going to have some things here that we do want displaying on the parent patch. Let me move this down a bit just to make this clear again. As we do this, we will see that this will become a viewable patch on the outside. Now I right click in the blank space here, go to properties. And I'm going to zoom in to see this better. All you do is check off graph on parent. Now if I hit apply right now, keeps this window open but applies that action, you'll see this gray rectangle here, which is representative of this red bordered rectangle here. This is the viewable area that will display here. It's showing gray right now because we have this subpatch open. As long as this is open, it will just be a gray box. But as we put things in it and then close this, just like these modules, things will display through. So now let me go here and I'm going to make it a width of, let's try 320. And its height doesn't need to be tall because I'm going to lay things out horizontally. 50. Press OK, and now our box becomes that size. And if I close this subpatch, I'm using Control W as a shortcut, Command W in Mac, and you'll see I now have this MIDI input module here. Looks like I could make it a little bit wider. I'd like it to cover, for now, at least the width of these two on the outside. So to do that, I'm going to go here, open it up. Right click again, go to properties. Let's make it wider horizontally. 320 wasn't enough. I'm going to just estimate 350, hit apply, and then I can see how wide that gray box is compared to these modules. Now there's space in between them, and we'll want to have space in between them anyway, but it looks like it's close enough. So I'll hit OK. Close this. And then I can arrange this like this so that these two fit under here. As we go, we'll adjust sizes to try and make it a nice looking display. Oh, I'm seeing here PD amp mod. No, I looked at first like something was interfering with its display there. Not really. But maybe I should make the same size as this. What I'm going to do is right click on it, go to open. Well, actually, it might be nice to see what the size of this is. I can estimate it's probably 20 taller. Let's open this. We're going to go to properties in here. And then we go to its height. 260. How about 270? Let's see if that's the same. I should have checked first so I could get the exact amount. Yep, looks like it's 260 because now it's too big. Nope, not properties there. You right click, open it up to open the subpatch. Then you go to properties on its background. I'll make it 260. And yeah, we go. They're the same height now. I'm going to adjust the internals to make it display like this one so things fit in a little better and look a little bit more consistent between the two patches. The main thing is to get this display down here. Trying to keep the borders, the margins even around the display. I can move this down a bit, I believe. Right about there. Move you down to. Now here, on-off is displayed above. Over here, yeah, it's displayed above as well. Ooh, but now these are lower than on the other side. Oh boy. Getting these even with one another. A little bit of trial and error. I'm leaving space here, and I do want space here because there's going to be more that will add to these modules. So to hook them up and have them working in the overall synthesizer. Try that. That's looking better. Okay, good enough. Now we're going to right click on this one, the new one, and open it up. Now at some point, what you do need to do, make sure whatever MIDI device you have is in, or is basically connected. Of course, any physical connections you need to do on your own, either using MIDI cables or a USB. I have a USB MIDI controller here, a small one that fits in my small laptop station here. And so I'm going to check the MIDI devices list down here, MIDI settings. And my input is set up as this launch key by Novation. That I do want as my input. Now my MIDI output I don't need to worry about because we're just going to be receiving MIDI in. Now, what things are we going to be receiving in? Well, I'm going to start making the little display here for that information that'll be coming in. We'll be adding more as time goes on as we add more features to the synthesizer. But right now, we want to be able to get in note values and velocity. Now, under the Put menu, you'll see here we've been using number boxes to display numbers and to be able to input numbers. But there's another one here called number 2, which has the shortcut Control-Shift-N. That would be Command-Shift-N in Mac. And that gives you a number box that looks like this. Looks a little different than the other number box. Has this little to the side like a sideways triangle. But the reason why I like to use these is these give you more options for your display. If I right click on the number box and go to its properties, I have this whole properties windows of things that I can do with it. Now what I'm going to do with this number box is have it be a display for notes. So I am going to, meaning musical notes to come in. And what I'm going to do is, first of all, it's width. This is in digits. MIDI note numbers range from 0 to 127. So that will be the only numbers coming in. That's only 3 digits long at maximum. So I'm going to change that to 3. So it doesn't need to be wider than it has to be. Its height is in pixels. just to make it display a little bit bigger, look a little nicer, I think I'll make it a 20 high. And then down here is its label. This is just a display name, but it still should be all like one word or different words separated by underscores. I'm just going to type note, because that'll be the MIDI notes coming in. And then here, I'm going to set up its send and receive symbols. This is so information can be sent to this box through its receive, and so the box can send information out its send. So I want to make unique names here. Once again, I like to use all lowercase and no spaces. So I'm going to say MIDI note, then underscore send. And then this one's going to be MIDI note underscore recv. Okay. Now I can also work with colors and stuff, but we're going to do that later. I'm going to show you in other episodes how to do some colorings and put background colors in and so forth to make our different modules look nice. Okay, there's note. Now I'm going to quickly just select this, hit Control D, Command D and Mac to duplicate it. This will just save me a little extra time in making this a velocity display. But I'm going to right click on it, go to Properties. Since it's for velocity, that's a range of 0 to 127 in MIDI, so 3 digits is fine. Its height is fine. Oh, and this is something we'll do to the other one too. You can put in a min and max, or low and upper value. Since 0 to 127 is all that MIDI velocity is, we can put that as a min and max. In case we want to type values straight into this, that way it'll make sure we don't accidentally type something out of range. Now this is no longer note. This second box is going to be velocity. And we need to change its send and receive symbols because they need to be unique to this one. So instead of MIDI note send, I'm going to make it MIDI. Here I'll just abbreviate it vel send. And MIDI vel receive. Go down, press OK. Now, as I said before, I'm going to reopen this one and put the same range limits on it. Go to its properties. The lowest value would be 0. MIDI note range is 0 to 127. And its upper max should be 127. There we go. All right, so this is where the note being played and the velocity will be displayed. But over here is where we're going to do the patching, here, or actually below, where we're going to do the patching for receiving this information in. Now what I'm going to do is make an object called, oh, it put it up there and hooked it up automatically because I still had the velocity number box selected. But here, I'm going to make it note in. Now there are some creation arguments that you could put after note in. I'm going to open up its help file to explain some more. Zoom out. Okay, this shows all the different kinds of configurations and things for note in. Note in, when you just make it without any creation arguments, has 3 outlets. First outlet will display a note. If any note data is coming in through the port you have selected as an input in Pure Data, which we did set a few minutes ago, it will come out here. The velocity of that note will come out here. And out here will come the channel that the note came on. Now, if you put in a default argument or a creation argument after note in space 1, that will be accepted as a channel. But then you only get 2 outlets for note and velocity, because you're telling it just to listen to channel 1 or whatever channel you put in here. MIDI channels range from 1 through 16. And then over here, this is a different object, control in, for MIDI controllers and so forth, and so on. These are a variety of other MIDI input objects. We're not going to do those until later. So right now, we'll work with note in. Now, the way I'd like to set this up is so that we can receive on multiple channels, but rather than this receiving on many channels, it'd be nice to be able to set it what channel it receives on. So I'm going to make another number box, and to save time, I'll just take this note box, hit Control D, duplicate it, and now I'm going to change its properties to make this a channel box. So I'm going to type channel here. And MIDI channels range from 1 through 16, so this only needs to be 2 digits in width. The largest one it can display is 16. And its height can still be 20 pixels. Its range, however, should be 1 through 16. That's the only thing that would be valid for our channels in MIDI. And now we're going to have MIDI underscore, I'll abbreviate it, CHNL underscore send. These are just habits I have. That's why I name them the way I do. MIDI underscore CHNL underscore receive, RECV. Okay. There's nothing else I need to change here. Press OK. And we're going to put it right here. Now this is going to be a little bit different. The other number boxes are going to just display the note and velocity coming in. The channel is going to be a way for us to select what channel we are on, so that this overall synthesizer will only receive on one channel at a time, and it'll be whichever one you want to use. That way, if you want to use this with a DAW software, some sort of sequencing software, or some way in which you have just this synthesizer receiving on one, and maybe another copy of it receiving on channel 2, you can set that up so that you can have multiples of these synthesizers working at once. So we need to be able to say, okay, channel 1, or whatever channel the user puts in here, is the only channel we want to receive on. Now, the way this works is note in will output the note, the velocity, and the channel out these outlets. And as you might remember, I've stated this before, in PD, the right inlet always comes first, and it'll just be fractions of a second before these come out. But this does come first. So what we want to do is set up something that will tell it what channel this note that's being received is coming in on. Because right now, PD allows you to select an input port. So that means a device on that port. But it doesn't, this is where you tell it what channel from that port to receive, 1 through 16. So what we're going to do is set up a select box like we've done before, SEL. Oh, I'm sorry. No, we're not. Sorry about that. Actually we are, but hold on just a second. The way we're going to do it is a little bit different. Well, actually, no. We are going to put it here. Okay. SEL. Now, I'm going to put in a default creation argument to make sure that we have a space here for something to be defined. But I'm going to put in something we'll never receive, which is -1. Why? Well, that way, this won't really work right until it receives a channel definition. In other words, the user needs to input a channel. Although since when a patch opens, you have a low value set to 1 through 16, when the patch opens, this will default be 1, the lowest value in its range. So that will come out here to this, so long as we have a load bang on it. We're going to need to make a load bang so that when the patch opens, the default value of 1 will automatically be sent. So that way, when this opens, 1 gets banged, and it gets sent here to -1. Well, select -1, and this -1 basically internally gets replaced. So what select is then looking for is the value 1. And if it is the value 1, it'll bang out this outlet. If it's not, it will put whatever number it gets out this outlet. But the way we want to use this is like an on-off switch. So if it's 1, we want it to send one thing. And if it's not 1, we want it to send another thing. And the thing we want it to send are messages. I'm going to make a message box here, Control-2, Command-2 on Mac. And I'm going to say 1. That's to turn on what we're going to be making later. Meaning the user wants to receive on channel 1 or whatever they put here. The select box finds out if it's that channel that this note and velocity are actually on. And then it's going to turn on something that we're going to have here as like a gatekeeper saying, okay, allow the note through, allow the velocity through. Or if it's not coming in on the selected channel, then it's going to send another message. And that message will be 0. Now, technically, you don't have to do this, but this is the way I like to do it. Since a number gets sent out here, meaning if it's not the number from the creation argument or what's been defined as the number to look for, it will put the number out here. But we want to use a trigger, that's the T, space B, trigger a bang instead. The B stands for bang, T stands for trigger. And it means when it receives something in here, the trigger is going to convert it into a bang. And the bang will bang this message, which is 0. In other words, to turn off the thing we're going to use as a gatekeeper. Now I'm going to take all this and move it right down here, so that when the channel comes in, the channel number, remember, anytime a note is pressed on the device you have hooked up to that Midi port, it will send that channel number into here. If it matches what's over here, and I guess you could really ignore the -1 for now, because 1, and in fact if we do this, go into run mode, type 1, the select is now looking for 1. It doesn't change the display here. It still says -1 because that's its default, that's its creation argument. But basically, anytime this opens, the load bang will bang 1 through. And so that way it's looking for 1. And if it's 1, it'll bang this message 1. And if it's not, it'll bang the message 2. the number 0, the message 0. And that will turn on and off our gatekeepers here. And now what are our gatekeepers? An object called spigot, S-P-I-G-O-T. And spigots receive through the right inlet ones or zeros to turn them on or off. I'm going to have them off to begin with. And we're going to need 2 of these. Spigot 0. What goes through the left inlet can be a variety of things. In this case, it'll be our note and our velocity. Now, when the note comes into spigot, it'll only go out the outlet here at the bottom if the spigot's open, meaning it received a 1. If it receives a 0, or hasn't received a 1 since being created, since its creation argument is 0, it will not pass it. But if it gets a 1, it will pass it. So we're going to hook this up here, and we're going to hook the 0 message up there, so that way the 1 and the 0 can be sent to the right inlet of spigot to turn it on and off. And we need to do the same with the second spigot here. Connect them both up. So now what happens is I'm going to put a number box, Control 3, Command 3 and Mac, just a regular number box down here below so we can test it out. Put another one down here. Now the idea is when we select a channel up here, like 1, sends it to select here. So now select is looking for the number 1. If here, through the channel outlet from note in, a note and velocity messages are coming through on channel 1, it'll bang the 1 here. Now if the note and velocities are coming on channel 2 or any other MIDI channel, it won't match what select is looking for. So select will send the number out here, which gets translated into a bang, and it'll bang this 0, thus turning off the spigots. So that way the note and velocity won't be allowed through unless it's coming in on channel 1. So we're going to test this right now. My MIDI controller, which is to the side of me here, I'm going to just press a note. And you see I got 57, so I obviously press MIDI note 57 at a velocity of 81. And then I'm going to release it. And you see it still says 57, but now it says 0 velocity. That's how PD handles MIDI note off signals. You get a velocity when a note's pressed, and when a note's released, it makes it 0, signifying that the note, it received a note off message, which means that note, 57, has been released. So we're going to need to work with that later to make that work the way we want to for us. But right now we can see, okay, my controller is set for channel 1, so everything was received. But if we only want to receive on channel 2, for example, now I'm going to press a different key, and you see nothing came through to change this. It still says 57, because that was the last thing it received. And you see the velocity is not changing because these notes I'm sending are on channel 2, which means select object is sending this note number here, the channel number here, which doesn't match 1. Note in is sending the channel number here, which doesn't match 2, excuse me, because that's what we set it to. Because it doesn't match 2, it sends the channel number out here, which gets translated into a bang, which bangs this message, turn off spigots, doesn't allow things through. Now, since we will eventually want to hear notes, I'm going to change it back to 1, which is the one that my MIDI controller is set for. So that way, we'll be able to see different notes as I play them. Okay, so that's some of the basics there of how to receive note and velocity in. Now we're going to set up something simple and basic here. Get this to the oscillator. Now, the first thing we want to do, though, is have them display up here. We made these displays to show the note and velocity. So we're going to do that next. S for send, space. Now, what was the receive symbol for note? Midi underscore note underscore RECV. So if we then hook this number box up, well, we don't need these number boxes anymore. That was just for my demonstration. Our new display is going to be up there. And now, what was the receive symbol for the velocity? We're going to send Midi DEL underscore RECV. So now that we're set to Midi channel 1, Midi note and velocity will be received and passed through spigot. And now it should display right up here. And it does. As I hit the keys. Even the zeros will be displayed. So that's good. So it goes up here. Now remember, these also have send symbols. So whatever they get in them, whether you type it in or it gets sent to it, will also go to its send symbol. So it can be sent somewhere else. And that's what we're going to do down here. We're going to receive its send by making a receive. Make an object, R, space, Midi, underscore, note, underscore, send. Since we're making a receive, this is to receive what is sent by this object. So the note box here is sending on this symbol, so we're receiving from this symbol. And let's make another one for the velocity. DEL underscore send. Now, what gets displayed here gets sent to here. Now you say, why not just hook these patch cables up and keep going? Well, the idea is I want them to be displayed so the user can see what notes and velocities are coming in. And then they get sent right back to here where they can be used. Okay. Now, we are going to eventually use these later. But right, because we have some patching we're going to put in here. But in order for that patching to make sense to you, I need to keep going and show you what's going to happen without the patching that we'll add here. And what we're going to do now is put something that will actually send this information via a different symbol so that the oscillator that we have can receive it. So the oscillator can receive notes and play them. So what we're going to do here is make another send. And in this case, we're just going to skip. We're going to call this is I need to use a different name. We're just going to call this, instead of Midi, we're going to call this note underscore REC. Now we didn't make a note receive yet, but we will. Here we're going to say send bell underscore REC. And where we're going to receive these is in the oscillator. Now the reason why I am doing this and not just having the oscillator receive the note and velocity from these symbols, because there's going to be patching I'm going to put in here after we do this. And you'll see why. I want to do it without the patching first so you can hear and understand why we need it. Okay, so anyway, here's our oscillator for playing things, OSC1. We're going to open it up. And now we've had some things set up here just so that to start with, it has the values it needs. We have a load bang here so that when the patch opens, we have a 0 going here so that the shape selector starts off on sine wave as a default. And we have a 1 here so that by default, it turns on metro down here, which will continually bang every 100 milliseconds tab right to display the waveform that's being generated. Okay, so we want to keep those. Now here, where we test and demonstrate these oscillators, where we sent like frequency numbers to the individual tab oscillators that oscillate the different wave shapes that get selected here, we're going to replace that, because now we're hooking up Midi functions so that this way it'll play what notes are received. So we don't really need, I'm going to do this because I like to keep my patches organized. I'm going to move load bang over here. Right now, these are the only things we're going to want sent when the patch opens, so that way we get display and we get a display of a waveform that's selected. But right now, these guys are going to receive frequency values that are based on the notes that are being played. So this is where we're going to put the receive note send. So remember, we put a send in the other patch, in the Midi input, to send out the note. And so here's where we're receiving the note. And the note is going to go to these oscillators. But these oscillators receive frequency values. Midi note values range from 0 to 127, and they're not the actual frequencies of the notes being played. So we need to convert them. Now, just so you can see how this conversion works, I'm going to do the following. I'm going to make a number box here, which will display the note being played. Now let me just play a note to make sure. Uh-oh. Playing notes, but I'm not getting them here. You got to check something. Note send. These are common issues in pure data. You got to check what you did. Send. Oh, its name is note receive. That's correct, because here, back here in the oscillator where we want to receive the note, receive. Now, the thing is, there isn't going to be a separate send and receive, so I think I'm going to rename these. Sorry that I sometimes do this. But just note, the synthesizer is only going to play one note at a time. And since there isn't going to be a separate send and receive symbol, we don't need to call it anything other than note. Because right now it's been officially declared that this is the note being played. And this velocity is the velocity that's going to be received. So we don't need the send and receive. That will just confuse things later. So anyway, we receive the note here, press a key, yep, it works. There we go. So we're receiving the note. Now we need to convert this note using a converter called M2F, MTOF. Now just to show you what it does, I'm going to make a number box. Oh, sorry, M2F. Control 3 or Command 3 in Mac to make the number box. Now when I press a note, here's the MIDI note, and then here's the frequency value of that note. I just happen to be pressing A440, which is MIDI note 69. So A440 is coming through. Now let's hook this up. To all of these oscillators. Now you don't need to worry about the patch cable covering the display, just like this patch cable wasn't a problem. Because patch cables don't get sent through. In other words, they don't display on the outside. So now I'm going to close this. Now, when I opened this up during my intro and it was making sound, I turned the DSP off. So I'm going to turn the DSP back on and play notes. Now, it's not going to stop. We have to go to DSP off here for now, so we don't drive ourselves crazy with the notes being played, because they don't go off. Because we didn't do anything with the velocity to tell the sound to go off. Let's open this oscillator up. Now, eventually we're going to do a better system than this, but right now, actually it'll be the DAC that we're concerned about. What we're going to do is disconnect all these cables going to the, because that's the sound going out. Actually, let's disconnect these two. That way our display will also show whether a note is currently being played or not. I'm going to move this Metro to the side here. Okay, so didn't disconnect this one here. So all these things need to be connected to here and to the DAC, but we're going to put a control mechanism in here to make sure that it only plays when a note's being pressed, and when a note is released, it stops playing the note. Now, a way we can do that, we're eventually going to change this because we're going to add something called an envelope that will allow us to shape the sound better in the future. That's another lesson. But right now, we're going to put in a quick and dirty way of turning notes on and off. And that will be by doing this. We're going to receive vel. Remember, I changed its name. No longer vel underscore receive. It's now just vel. And vel is a range of 0 to 127. But when we're using these star tildes and everything to control the amplitude of sound, remember that amplitude of actual audio signal is a range of 0 to 1. So we need to convert MIDI velocity into audio amplitude, which is a range of 0 to 1. An easy way of doing that is to take whatever number's coming out here as the velocity and dividing it by 127. Why is that? Well, if you take a certain range and divide it by whatever the maximum of that range is, it's basically making it a percentage. You see, I still have these in there. And so I am going to put down here a number box so you can see that. I'm going to press a key hard. Obviously, I pressed it at 127 because 127 divided by 127 equals 1. Now I'm going to do it softer. And you see I get 0.71, 0.716. So basically, unless you can kind of like press it down really slow, I still get a 0.007. So depending on how hard or how fast really you hit the keys, you're going to get a range of 0 to 1. 0 meaning no sound, and that's what comes through as a 0 velocity, because 0 divided by 127 equals 0. That means note off. And then everything else is a range of whatever velocity came in, but converted to 0 to 1 rather than 0 to 127. And then this is fine for telling our, I'm moving it over here, telling our signals here how loud they should be or what their amplitude should be. Now what I'm going to do is remember the whole thing, like the reason why we put these pack F50s and line tildes in here was so we wouldn't hear artifacts or the snapping sounds when audio levels change suddenly. We don't want them to change that suddenly and hear snapping in between. So we're going to use these again. I'm going to take this and duplicate it. Grab it while it's blue. Drag it over here. And then hook it up. Because this will go from velocity value to velocity value, 0 to whatever number it is in a range of 0 to 1, which is actually amplitude values, not velocity. It'll go to that over 50 milliseconds, which will keep it from making that snapping, so known as creating an artifact. Okay, so then this can be plugged into a star tilde. Star tilde, there we go. This will govern, this star tilde will govern the amplitude values that go to tab right, well as to DAC. And I'm going to put it to both left and right inlets so we hear it both on the left and right sides. Its right inlet is going to receive this here, because this is what at the audio rate is being multiplied by the signals coming here, allowing us to change their amplitude. And when that 0 velocity comes through, it will zero it out and actually turn off the note. Okay, save and close this window. Well, here we go. I'm pressing a key. I have DSP off, so actually I should turn it on. I press the key. Here's its note being converted to frequency. And here its velocity came through and got converted to something about 0.700 or something like that. This changed it to that value over 50 milliseconds, so it sounds instantaneously to us, but it actually sloped it down so we wouldn't hear a snap. And that is basically being multiplied by these amplitudes. So I'm going to hit the key real soft this time. Quieter. Now I'm going to hit it harder. Louder. So we actually are getting some velocity response here. Now, we are going to add more things to the synthesizer that makes it even better than that, with an envelope and everything to craft the sound better. But at least now, and I'm zooming out so you can see the outside, when we close this window, this is our sound oscillator here, and you see it's flatlined. That's because it's not playing anything. Now it is. Now it's not. And I can go into run mode and select different wave shapes. Now you hear that bloop, bloop, bloop. That's what we're going to have to fix yet. And this will be the last thing in the lesson. And it's a little shorter this week. But that's the thing in the lesson that I was saving. Remember I said there was more patching we're going to do in Midi input? That's what we're going to do now. Because, for example, I'm holding down a key now. Now when I play another note, it kind of glips off like that. The reason why is when I press the other note, it started to go to it, but as soon as I released the note before, a zero velocity came in and shut off the sound. So we need to do something to fix that. This is a monophonic synthesizer that we're building, meaning it'll play one note at a time. So as it plays one note at a time, those velocities will go to different notes. Like I'm going to hold a note now. And now I'm going to keep holding it and I'm going to play another note. It went to it because a new note value came in and the oscillator started playing the new frequency. But now if I release the first note that I'm still holding down but we don't hear because it was replaced by the other note, it turns it off. Okay. And basically that means that when you want to play like a little melody, it's going to sound kind of like that. Because all your note off signals are coming through and turning off sound. We don't want that. We want to basically have some sort of control over what note off signals are coming in. Okay, so we are having a Splice edit here because I wanted to make this a bit better of an explanation than what I did the first time. Fortunately, I'm recording and can do edits, streaming live. So anyway, all I did, what you see so far is the patch as we had it. And I just moved these down further. The note and velocity sends that go to the oscillator. And I just opened up some space in here so that we can do the patching that we need to. Main idea, as I was explaining, is that we need to regulate when zero velocity is allowed to come. Now, what we're going to use here is an object called strip note. Now, what strip note does is it will receive note and velocities as a combined message. Now, when they come out of note in, you could have them both go straight into a strip note and do things that way. but I have all this stuff up here to regulate the channel and all that. So we're going to do it a little bit later. But since we need to a little bit further down in the patch. But since we need to send these pretty much as a combined message, we're going to use pack for that. Remember the object pack that we use to get rid of artifacts? This essentially just takes multiple things and puts them in one message. Objects that want to receive them as one single message, and strip note does. I'm going to say pack FF, where once again the F stands for float, which means numbers in computer programming, but it allows for numbers that have a decimal point in them, and a variety of numbers afterward. This is a bit of an oversimplified explanation, but it's good enough for now. Basically, it allows for numbers that are not just integers, integers being a single number with no decimal point. So anyway, if we pack these together, basically what happens is the note and velocity values are being sent to strip note as one single message. So they'll come out the left outlet of pack and right into the left inlet of strip note. Now what strip note does is it checks your note and velocity. And if the velocity is 0, it won't put anything out. If the velocity is not 0, it'll put out the note out here, and it'll put the velocity out here. So if we basically have no 0 velocities coming through, we do want to hear those notes and have the velocity come through to regulate its amplitude, as we've done with our shortcut to having amplitude being governed by velocity put in. In other words, we want the information to pass. But if there's a 0 in the velocity, we need to do a check on it. So we're going to have a second area here for doing that check. Basically, we can do that by always trying to get my patch cables straight. Like an exercise in futility, I guess. But there we go. Got it. Now, what we're going to do here is make a trigger, bang, float. So what triggers do, if you remember, is they combine a bunch of actions, and you define what those actions are based on what comes in it. And what's going to come in here is a number for the note. But what's going to come out is the first outlet's going to make a bang, and then the second outlet will send a float, meaning a number. And it'll be that number that you're sending in. So basically what happens is by sending a number in here, which is the note, it'll send a bang out here, and it'll send the note out here. And the reason why we want to do that is we're going to take make an object and make what's called a float box. Simple abbreviation of F, Splice, or the full word float. Now what a float box does is it has 2 inlets. The left inlet, if you send a number through, it'll go straight out the left outlet. If you send a number into the right inlet, it'll store it. And that's what we're going to do right here. We're going to take the, oh, come on, get it. All right. We're going to take the velocity messages coming in. Now this is before strip note. So this is the notes and velocities. They may have velocities of 0s, may not. But we're going to have them come through here anyway. So we can determine if the 0 velocities that come through are ones that we want to send through. So what we do is we store velocities here in this float box. And when a note comes in, it'll bang the float box and bang the velocity through. The reason why we're doing this is we want to basically try to keep things in the same timing. When note and velocity messages come through, Remember, the rightmost thing is first. That's up here in note in. Channel comes through first, so we can make a determination if the channel's the right one to turn on or off the spigots. Velocity comes next, and then note. Now they come in such time frames that are so close together in time that it takes a computer programming language to determine which was first or not. But there is a slight difference where the rightmost one is coming first. So we need to deal with that. Sorry, straightening out lines again. Sorry, I'll stop. So anyway, with those floats messages, the float messages, the number messages coming out of note velocity, we want to do this determination in a way where everything's going to happen at the same time. So it's not until the note gets through that we want the velocity to come out. Okay, so that's why we have this set up this way. You see the patch cable going to the trigger bank float is coming from the note message. And then the velocity message is getting stored here in float. So when the note message gets through, which is just a little after the velocity message, it'll bang float and send the velocity message out. And this is where we're going to use a select object, SEL0. In this case, the select object will find out if that velocity is a zero velocity or not. Since we're taking them from here, or they've gone through strip note, it could be velocities of 0 or anything else. But we just want to deal with it if they're 0. So this determines that. So basically, select will bang out this left outlet, if the velocity coming in is 0. See, it gets banged out of here, and if it's 0, it will bang out this outlet where we want something else to happen. And this is where we're going to have another float box. Now this float box is going to store what comes out of this outlet here, which is the float or the number that is the note. So the note bangs this to happen, but it also comes out here where it's stored. So once this happens and determines whether it's a 0 velocity, if it is, we bang this float box that's storing the note and then do a determination on it. Now the thing is, we only want 0 velocities to come through when the note being played or the last note being played is released. Like when you play a note and then go to another note, if you release the first note after you've already pressed the next note, you don't want it cutting off that next note. So you don't want the 0 velocity coming through. That's what that cutting in and out of the sounds was. So what we're determining here is, okay, this note that's got 0 velocity that's being released, is it the same one that was most recently pressed? That we can determine by getting out a strip note. Since strip note's note outlet is only sending those notes that did not come with a 0 velocity, because it cuts out the rest that do. So by doing that, we can determine if this, which will be the last note without a 0 velocity, is the same as this note here that came through with a 0 velocity. If they're the same, that means the last note played is being released, and we do want the 0 velocity to go through. So basically, if this note here that came through a 0 velocity matches this note that was last played without a 0 velocity, then select will bang out this left outlet here. That's where we're going to put a 0 message. That will be the only way that a 0 velocity will go through to the oscillator. Okay? So that is the whole idea here. We're separating those things that come through without zero velocity and those that come through with. These are note offs, but we only want the note offs to come through if they were the last note that was actually pressed down. Otherwise, ignore them. That's why the outlets of these select objects on the right-hand side, meaning that they're not matching what they're comparing, go nowhere. We don't want that to happen. So let's test it now. Saving, and I'm closing this. Okay, I got a problem. Oops. I don't know what that is. I hit the wrong shortcut there. Trying to turn off DSP. Okay, there's an issue with what I did. I need to check it. Okay, let's see here. Notes are coming in. When the note comes in, that's when we want to bang whatever the most recent velocity was. Make sure velocity is hooked up to the right side. When you click on a cable like that, it highlights blue, so I can see which is which. Yeah, that's hooked up right. So that comes through, it gets tested as to whether it's zero. Of course, the note itself is being stored. If it's a zero velocity, it'll bang out the note. Where this note then gets, I have these switched. We want to compare this note to see if it matches this note. Can't have them reversed, because what select does is it will see if this on the left inlet matches this on the right inlet. And then that's where you'll get the yes or no response as to whether it bangs out this left outlet. See, this one is the one that's come through with the zero message. That's the one that we want to check. We don't want that note trigger a zero velocity unless it matches the last note being played. So I had them reversed. But anytime I make mistakes like that, it's good information for you, because you'll see some of the common mistakes that are made and how to fix them. Oh, I have DSP off because I turned it off. There we go. I'm just messing with the keyboard so it doesn't sound smooth, but you know. Now, you will still get some glitches if you play inaccurately. Like, I played a note there and bumped another key because my finger leaned over a little bit, bumped another key. So it got a note on and then a note off right away. And of course that checks out, so it turned off sound. So basically, this patching helps you to play monophonically. But it will still, like if you play something wrong, like you bump another key, you can still, knock off the sound. So it's a bit of protection. It allows you to, play through some notes like that, and it won't cut things off. But yeah, in your act of playing, if you accidentally bump a key and release it, it'll release because it was the last note that was played. So in other words, you still, if you want to play keyboard well, you still got to play keyboard well. But it at least will keep you from shutting off notes as you play one after the other in succession, which you frequently will do. So there we go. That's this week's main part of the lesson. I think there's one little thing that we will do up here, though. I know I've been changing this a little bit as we've been going, but the idea is I want to make things a little bit more accurate or useful, user-friendly. So it'll be worth it in the end. I'm not really going to add anything else. We're just going to change something around here. These receives here are the things that display your note and velocity. There's no point at this point to have notes that are being edited out, like the zero velocities that we're eliminating. We don't need those displayed. What I'm going to do is this. We made some extra stuff that we didn't need to. I'm going to move these out of the way. Basically, we're going to take the spigots here and hook these up directly to our new patching for monophonic playing. So that means the note needs to go in here to the left inlet of pack, and it needs to go into the left inlet of the trigger here. The velocity goes into the right inlet of pack, and it goes into the right inlet of this float box here, where it gets checked. There we go. Now we can move this stuff up. Now, I'm going to get rid of these, the note and vel here, which means we'll need to rename them in the next patch. But these should actually be the sends here to go to the displayed notes. So here's where we get our note values. And this is where we get our velocity straight from the right inlet of strip note and from this message box. It'll be the only zero velocity. So now what's happening is the results from here I'll stop it. There we go. Are going straight up here. Now, these are receiving from these. We could just delete them here and receive them straight in the oscillator section. So that way we don't have extra sends or receives that we don't need. And another thing that we're going to do here, I showed this just to display how M2F works. We don't need these extra number boxes. As we go through this, there'll be some things I'll put in for explanation, learning, and I'll take them out again to make things more efficient. Like we don't need it going through a number box there. Or two different extra number boxes. It just needs to be converted. And now we're not receiving from note anymore. I deleted that. We're receiving from Midi note send, which is the display box. Send. So it goes directly here. And down here where we're receiving velocity, we're now receiving Midi underscore velocity VL underscore send, which is coming from the display box at the top. So there we go. We've eliminated extra stuff we don't need. Everything works. Now, if you don't have an external MIDI controller and you haven't found like a virtual MIDI controller yet, here's one way you can test this out. You could type in MIDI notes here and they'll still be sent to the oscillator. Say you play MIDI note 440, 69. Give it a velocity and we'll hear it. Type in 100. Then type in a 0 and you don't. Now that's a pain in the ass way to play music, but that's a way to check this out to make sure it's working. One other thing to fix here, look at this. We have the name of this subpatch crashing into the display there. So let me fix that real quick. Open. I want to get into the habit at the end of each of these sessions, just doing error checking and making sure everything works properly, and also some other cleaning up. We need to make this taller, so I'm going to make it, instead of 50 pixels tall, 75. And then move these down. On the inside of the subpatch, you don't see that displayed name of the patch at the top. But on the outside, you do. And so there we go. Neater and more organized. We'll be doing plenty of things to make things look better as we go. But right now you can see some of the conversion that comes in to play when you're converting what do you call it? MIDI into audio signal. I'm going to make this a little bit smaller for now so I can do a nice screenshot of this. Keep that up. And there we go. There's the screenshot. Okay, now one last thing that's good for testing. I'm saving at this point, Control S, so everything's closed. And the next time I open it, it will be that way, where we only see the parent patch. And this is what you want in error checking your stuff. Open it up, and this is how you test it. Play your notes. You know, and if you want to make sure that other stuff we've done in the past works right, there we go. There. Now, this stuff's coming in the future. This will do something someday, but let's leave it the way it is for right now. All right, folks, thank you for joining me this week. Found it valuable? Please do subscribe. Please do like, whatever you can to help about the series. Share it on your social media and so forth. I really appreciate anything you can do to help me out and keep this series going and also expand it. So that's it for this week. I'll see you next week.